Hi, Integrated Math 1. Welcome to lesson 2.4.1b, where we're going to continue classifying shapes on the coordinate plane. So we are still going to be using our graphs. You may at some point want a straight edge to help you out with that. We're still going to be using distance formula. Remember, we were using that last time. We're going to keep using that today. So we are going to be doing that today. That does mean that you're probably going to want a calculator handy as well as we go into today's lesson. So just a heads up. So just to remind ourselves of what our goals are throughout these couple days here. We learned about distance formula. We learned about midpoint formula. Now we're going to use those tools to help us classify a quadrilateral given the locations of its vertices on a coordinate plane. A quadrilateral, of course, has four sides, but is it a square, a rectangle, a rhombus, a trapezoid? None of them. What exactly is it? We're going to classify our triangles using our distance formula and also using Pythagorean Theorem, oddly enough. We're going to classify our triangle. Is it acute, obtuse, right? Is it isosceles, scalene, equilateral? Like, what are we looking at here? And the cool trick, actually it's probably the easiest one today, is we're going to determine the coordinates of a fourth vertex given the coordinates of three vertices of a quadrilateral and a description of that quadrilateral. So I have three vertices. If I want it to be a square, where should the other one go? If I want it to be a rectangle, where should the other one go? If I want it to be a parallelogram, where should that fourth point go? So we're going to play with that some more today. And just really start diving into that whole classifying triangles and quadrilaterals by the lengths of their sides and the measure of their angles. Only now they're going to be on a coordinate plane. So we're going to go over to page 250. And again, I do apologize. We're going to be jumping around a little bit. We're going to go over to page 250, and I want you to determine whether this quadrilateral, EFGH, can be classified as a rectangle. And I do want you to justify your reasoning. Now, you could totally use distance formula on these. That would be okay. But I think because we know rectangles have right angles, we know that the sides are perpendicular, right? You might want to start by looking at the slopes. You might want to find the slope of each side, the rise over run. Go ahead, hit pause, see if you can find the slopes for each side, and then hit play when you're ready, and decide whether it's a rectangle, and then hit play when you're ready to check your work. All right, let's find the slopes. I got my pen ready. Do you have your pencil ready? I got my pen ready. Here we are. So if I want to find the slopes, I need to make sure, I want to know if it's a rectangle, I know that I should have perpendicular sides. All right. Make a note of that. Ooh, that did not fit on my page. I want my sides to be perpendicular. That means the slopes, if you recall from an earlier unit, on perpendicular lines, the slopes are opposite reciprocals, right? One's positive, the other's negative, right? Do you remember that? Remember that? All right. And of course, if it's 1/2, the new slope should be 2/1. So we have to change the sign and flip it. So let's just start by finding the slopes. To get, let's start with EF. To get from E to F, it looks like I have to go down 3 and over 4. So, 1, 2, 3 down, 1, 2, 3, 4 to the right. That means the slope of EF is -3/4. Sorry, I hit a funky button there. I will hit the correct button. There it is. So my slope is -3/4. Huzzah! Let's do the slope from F. I want my pen back. Let's do the slope from F to G. It looks like, and actually maybe I'll go G to F. That would probably be easier. Looks like, because I want to do my rise first. So it looks like I have to rise 1, 2, 3, 4, and then I run 1, 2, 3. So +4, +3. So it looks like the slope here, just kidding, is +4/3. This is already a good sign, isn't it? Because I can see that these two guys are opposite reciprocals. I can see that that's a right angle. So that's a good sign. Let's find the next slope, GH. Let's see. And I think it's easier to go from H to G. It's easier to go right to left, So from H to G, I have to go down 3, so that's a negative 3, and over 4, that's a positive 4. So that means the slope of HG is going to be, if I hit the correct button, which I will, is negative 3 over 4. Ooh, these guys are also opposite reciprocals. That's a right angle too. Oh, this is good. This is good. If I can show these are all right angles, we're going to be doing great. One more slope to find from H to E. Looks like I have to go 1, 2, 3, 4 up, and then 1, 2, 3 to the right. So that's a rise of 4, a run of 3. So the slope of HE is 4/3, which is also opposite reciprocals, isn't it? So I know that's a right angle. But check it out, 4/3, negative 3/4. If I'm talking EF and HE, also a right angle. Oh my gosh, I got nothing but right angles here. Since the slopes are opposite reciprocals, the sides are perpendicular to each other. So we've got 4 right angles. So yeah, it's a rectangle. It's, oh, actually, I'm gonna do it this way. Let me erase this. I have it all pretty and typed. I'm gonna use the pretty typed bit. Erase that. So yeah, quadrilateral EFGH, EFGH, there it is a rectangle. Yes, it is. Okay then. So I know this is a rectangle because I have 4 congruent angles. Yay, 4 right angles. But is it a square? Can you use distance formula and decide whether or not it's a square? Go ahead, use the distance formula, see if you can use it for all 4 sides, and see if you can figure out whether or not this is a square. Hit pause, work it out, hit play when you're ready to check your work. So I'm about to go distance formula crazy on this. First of all, I need my points, right? We already know there are 4 right angles. Like we did that on question 3. Like we already did that over on the other page, 250. By the way, this is on page M2-251. So I already know I got 4 right angles. But I need to know if I have 4 congruent sides, right? That's the deal. So let's see what we can do then. E has points at 2, 3. F has the coordinates for F, it looks like it's at 6, 0. So for EF, I'm just going to do some quick Pythagorean theorem. Subtract my x's, right, x, y, x, y. Subtract my x's, so 2 minus 6. Subtract my y's, 3 minus 0. And we'll do a big square root there. Of course, 2 minus 6 is negative 4. 3 minus 0 is 3. Negative 4 squared, negative 4 times negative 4 is a positive 16. 3 squared, 3 times 3 is 9. If I add those up, I get 25. Oh, this is nice. I don't even need a calculator. The square root of 25 is 5. I know that one. Hey. So yay, EF is 5. Now, if all of the other sides are also 5, we've proven it's a square. So let's do some more work. I'm going to grab another color just to kind of help change things up. So FG, I know F is 6, 0, so X, Y. G, it looks like, is at 3, negative 4, right? 3, negative 4. So again, X, Y. So let me subtract my for FG. So 6 minus 3, subtract my x's, squared, plus 0 minus negative 4, squared. 6 minus 3 is, of course, 3. 0 minus a negative 4, minus a negative, that becomes a plus. So 0 plus 4 is 4. 3 squared is 9. 4 squared is 16. So starting to look familiar. 9 plus 16 is, of course, 25. And square root of that is 5. Oh, that's a good sign. So they're both 5. Awesome. Let's double check the other sides as well. GH, I'm going to grab another color here. So GH, I know the coordinates for G, again, X and Y. Coordinates for H, it looks like -1, -1. Okay. Again, X and Y. So let's do a little distance formula here for GH or HG, whichever way you want to think of it. So I'm going to subtract my X's, -1 minus 3 squared, plus subtract my Y's, -1 minus a -4 squared, big square root. -1 minus 3 is, of course, -4. Ooh, minus a negative, double negative makes that a positive. So -1 plus 4 is actually 3. My pen keeps being weird today. -4 squared, -4 times a -4 is a positive 16. 3 squared, 3 times 3 is 9. Again, I'm having deja vu, are you? 16 plus 9 is 25. Square root of 25 is 5. Awesome. So far, everybody matches. 5, 5, 5. We have to make sure the last one matches. You have to prove all 4 sides are congruent if you want to prove this thing is a square. So last set of sides, let me do one more color here. So let's do HE. So my coordinates XY, XY, awesome. So 2 minus a -1 squared plus 3 minus a -1. Oops. I got to make sure I get all the negatives in there. So 3 minus a -1. All right. Of course, we know the double negatives become positive, so that's nice. 2 plus 1 is, of course, 3. 3 plus 1 is, of course, 4. 3 squared, 3 times 3 is 9. 4 squared, 4 times 4 is 16. If we add 9 and 16, we get 25. The square root of which is 5. Ah, they all match. Yay! So, yeah, we have 4 congruent sides and 4 right angles, which we proved earlier. Dude, this is a square. Hang on, let me erase all of this. Oh, I know, it's so beautiful, and you just want to stare at the colors forever. I'm going to erase it all real quick so that I can bring up my pretty typed stuff. So we found all the sides were 5. Yay, us. So it has 4 congruent sides and 4 right angles. Yeah, a quadrilateral EFGH is not just a rectangle. That is a square. Now, we've analyzed our rectangles. Let's talk triangles. You remember Pythagorean Theorem? The whole idea that if, and it only worked on right angle triangles, but a squared plus b squared equals c squared. C squared is your hypotenuse. It's always opposite the right angle. It's always the longest side. Do you know that Pythagorean Theorem can go further? Did you know that? Check it out. Let's say you don't know if it's a right triangle. What you're going to do is you're going to pick the longest side and you're going to make that C. So you're going to pick the longest side and make that C, and then your other 2 sides will be your A and your B. And here's what happens. If C squared exactly equals A squared plus B squared, it's a right triangle. You have a right angle. If your C squared is too small, your C squared is too small, so your C squared is less than your A squared plus B squared, then that means you've got acute angle going on and it's going to be an acute triangle. If your C squared is too big, right? So C squared is too big. This is on page 254, by the way, if you want to make some notes there. If your C squared is too big, C squared is greater than A squared plus B squared, that's bigger than a right angle, and that's going to be an obtuse angle, so you're going to have an obtuse triangle. So you can actually use Pythagorean Theorem to classify whether your triangle is right, acute, or obtuse. It's such a cool trick, and it all is about C squared. Is it just right? It's a right triangle. If C squared is too small, it's less than, it's going to be acute. If your C squared is too big, it's going to be obtuse. So can you start off? Let's start off just by graphing triangle JKL. Can we just graph it? Point J is at -2, 4. So -2 up 4. We're going to make a little point and call it J. K is at 8, 4, so I'm going to go right 8 and up 4. Make a little point there, and we'll call it K. And then L is at 6, negative 2, so I'm going to go right 6 and down 2, make a little point, call it L. And we'll connect these to make a nice little triangle. So here's what I want you to do. I want you to start by using distance formula to decide if this triangle is scaling, isosceles, or equilateral. So start by using distance formula for all three sides. And by the way, this is the next question, question number 4, part A. Can you use the distance formula for each three sides and decide if this is scaling, isosceles, or equilateral? Go ahead, hit pause to work that out, hit play when you're ready to check your work. So I'm going to start with side JK just because it's the easiest one, because I actually don't need to use distance formula here. Let me grab my red pen. Check this out. It's flat. I can just count. So if I get from J to K, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, JK is a length of 10. Awesome. I do need to use distance formula for KL. So for KL, this is my X, this is my Y, this is my X, this is my Y. So I'm going to subtract my X's, subtract my Y. So 8 minus 6, 4 minus a negative 2. I need to clean that up a bit. 8 minus 6 is, of course, 2. 4, that's 2 squared. Yeah. 4 minus a negative 2, that becomes a plus. So 4 plus 2 is 6. And I need my calculator. I will in a minute. 2 squared, 2 times 2 is 4. 6 squared, 6 times 6 is 36. If I add those together, I get 40. And I need a calculator. Square root of 40 is about, it's not perfect, but it's about 6.3-ish. Wow. Well, I know it's not equilateral because I definitely don't have 3 congruent sides. But let's go ahead and use distance formula one more time just to see if the other side matches, right? Because I've got a third side here. I do want to make sure that third side matches. Maybe it's the same as this one. Maybe it's the same as that one. Let's find out. So let's go ahead and do some distance formula here from J to L. So now I need to go from J, XY, to L, XY. So negative 2 minus 6, 4 minus a negative 2. I'm going to come back over here. I'm actually going to erase all of this. I don't need it anymore. So negative 2 minus 6, and then 4 minus a negative 2. Of course, 4 minus a negative 2 is a plus. So negative 2 minus 6 is negative 8. Squared. Plus 4 plus 2, that is 6. Squared. Negative 8 squared, negative 8 times negative 8 is 64. 6 squared, 6 times 6 is 36. If I add those together, my trusty calculator, I do get 100. Oh, I know that one. That's a nice one. Square root of 100 is 10. Ooh, and look at what's happened here. I'm going to erase this so you can see the pretty typing instead of my sketchy handwriting. Check it out. JK and JL have the same length. They're not the same as KL. This is an isosceles triangle. Yes, it is. It's isosceles. Well, then let's take this a little bit further then. Remember what I was just saying about the Pythagorean theorem? Pick the longest side to be C and plug in C squared, A squared plus B squared, and decide if the triangle is acute, obtuse, or right. Hit pause. See what you can do with this. Hit play when you're ready to check your work. You ready? So we had a side that was 10. We had a side that was a square root of 40, or about 6.3. And then we had a side that was 10. Well, 10 is the longest. So I'm going to make this guy my C, and that means you can be A and you can be B. Yay. All right, great. So let's see what happens if I do 10 squared. And I don't know what's going to happen. I don't want to use the decimal. I'm going to go ahead and use the square root of 40, and you'll see why in a minute because I'm going to square it. So c squared, a squared plus b squared. Of course, 10 squared is 100. I know that. The reason I did this and not the decimals, check out what happens. A square root of 40 squared, remember that squares and square roots, they cancel each other out, right? They cancel each other out. So that means I'm just left with 40. Of course, 10 squared is 100. And then I can add these. 40 plus 100 is 140. Oh, no! Oh, my c squared, a squared plus b squared, my c squared is too small. So what did we say earlier about that? What did we say earlier about that? I believe that means it's smaller than a right angle. It's an acute angle, right? Oh my gosh. Here, I'm going to erase this so we can see the pretty typed stuff. Triangle JKL is an acute triangle. My c squared was too small. So sad. One last little trick, and this one's the easiest and the nicest one of all. So you've been classifying quadrilaterals by their sides and angles. Sides congruent, are sides perpendicular, parallel, are what kind of triangle, what kind of quadrilateral is it? Now, you can actually use this information that you know about quadrilaterals. Like, I know rectangles have 4 right angles. I know rhombuses have 4 congruent sides. I know parallelograms, their opposite sides are parallel. You can use this to create a quadrilateral on a coordinate plane. So here I have 3 points, A, B, and C. A, B, and C. I want you, and I'll let you play with it before I show you my trick. I want you to plot point D. I want you to put a point D on here somewhere such that ABCD is a square. Go ahead, hit pause, see if you can figure this out, and then hit play when you're ready to check your work. All right, maybe you figured this out, maybe you need a little help. Let me show you what my thinking is. I know that squares, the sides are congruent, right? I also know things that like the sides are parallel, right? Maybe I'll put opposite sides are parallel. Abbreviate that. Opposite sides are parallel. So here's what it boils down to. My thought is that they should have the same slope. So you're ready to watch this trick? Watch this. I know D should be out here somewhere, but I know that side CD should match side BA. So I'm going to use side BA, and I'm just going to count my rise and my run. So to get from B to A, I have to rise, let's see, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like I need to rise 10. And then I need to run. So 1, 2, 3, let me make sure I count it right. 1, 2, 3, 4. So it looks like I have to run 4. So I know that side CD should match side BA, right? These should be the same. They're across each other. So I'm just going to do the same thing for C. To get to D, I'm going to need to rise 10 and run 4. So I'm going to rise 10 from C. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I will run 4. Oopsie. 1, 2, 3, 4. And right there, people, right there. Sorry, it's being all weird on you. Whoa, go back. Right there. That is where point D should be. And you can connect them. I would use a straight edge instead of Miss Scott and her sketchy little, I'm trying to do it by hand with my sketch pad. It doesn't work too well. This should be point D. Write down the coordinates. I need to write down the coordinates. It looks like in order to make a square, D needs to be at 5. And I go over 5 and I went up 3 at 5, 3. So that's where D needs to be to create a square. I just used the opposite side and said, I had to rise this many, run that many, and I did it over there. Not the only way of doing this. a way of doing this. Works for me. Hopefully it'll work for you too. As always, I hope you found this helpful. I hope you found this useful. If you got questions or concerns, let me know. Come talk to me. I'll help you out. And I'll see you guys soon. Bye.